Hello, good evening everyone. How are you all feeling now? So I guess your preparation is good as of now because we did all physical or inorganic even few hours ago, all organic as well. So basically this session is going to be really precise one. Let me tell you, I will not probably be interacting with you people that much. Rather I'll be focusing on the concept, because not concept rather than that of the question, because please, as you have seen the thumbnail, this is going to be the paper predictor for your tomorrow's examination. So yes, if you really want to get this question in your upcoming examination, learn it by tonight, because you will not get back this time, right? So yes, without further delay, let's get started. So first, very fast I will go. Again, I'm telling you, with the answers and all, with very fast I will go. Okay, so yeah, let's go ahead. So this is, you can see, first I have kept the entire formula list of the physical chemistry. Okay, so if you know these formulas, you can solve the physical chemistry problems. So yes, I know you people are very much expert to take a snap. Please take the screenshot, that's gonna help you. Next here you can see this is complete organic. Okay, this is basically complete organic in a single slide. Okay, all the reactant, reagent and product. So yes, if you really want this, take a screenshot. It's really gonna be helpful for the last minute revision. So yeah, the session is, again I'm telling you, tomorrow is your exam. You have to prepare for yourself, right? Self-study time. So I won't take that much time. That's why the session is really precise, and only the most important question I will discuss that you are going to face tomorrow. Okay, so yeah, numerical problem I will show you, and you can see here a chat is pinned from our Deeksha Karnataka channel. If you are having any doubt in MCQ video you will get over there. Any doubt in numerical problem, please go and watch 50 numerical video I made, and physical chemistry also, physical and inorganic complete video, complete live session we took, that also you can check over there for the numerical purpose. Numerical I'm not going to do, but I will tell you which are the most important numerical here. Okay, let's go ahead. So here again I'm telling you, these are the chapters that should be your focus zone, okay, in order to get maximum marks. Solution, chemical kinetics, coordination, D and F block, haloalkanes, haloarenes, alcohol phenols, aldehydes. Finally, go ahead with the amine first, then biomolecules. If you're not confident, then electrochemistry, little bit theory you will study. That's it. Let's go ahead. First we will go with the solution chapter. So again, Henry's law, you can see Henry's law, mathematical term, P equals to KH into X. What is the significance of KH? It's going to be very important, and also the relation of this thing, relation with temperature. Okay, that also going to be important. Wait just a minute. Okay, and the relation with the temperature is also important. Relation of temperature with solubility and KH, that is also super important. Okay, so yeah, let's go ahead. Here you can see, just a minute. Here comes the next question. You can see, that is state Raoult's law and give the mathematical form. What is a vapor pressure? A vapor pressure of CH-Cl3 and CH2Cl2 is given over here, and you have to find out which one is more volatile. Okay, so Raoult's law is one of the very one of the most important. You can see this is the answer here. Write properly the expression of Raoult's law and mention the proper abbreviation of it as well. Okay, next, as you can see, the vapor pressure for these two cases are mentioned. One is for CH-Cl3, another one is for CH2Cl2. CH2Cl2 is having more vapor pressure and hence it is more volatile. Next question, here you can see, write the expression for the cryoscopic constant and change in enthalpy of fusion. So this is the expression. Wait. So for this case, the expression is for Kf. So Kf, whatever the expression you will study, that is the cryoscopic constant expression, and that is with respect to the enthalpy of fusion. Next, if you go further, that is the variation of vapor pressure of solvent and solution with respect to the temperature. So vapor pressure with respect to the temperature, as you can see, there will be an increase in temperature. That is a relative, increase in the there will be a increase in temperature, right? Elevation in boiling point, that you have to show here. Next, let's go ahead, give difference between ideal and non-ideal solution. So I don't have to explain, I guess. This is the normal the differentiation type of question. So pick any 3 out of it, 3 marker question you will get out of here. Next, here you can see difference between the types of ideal solutions. So that's going to be basically the positive deviation and negative deviation of Raoult's law. So these are the difference in between them. Avoid this particular point. This is wrongly mentioned here. So rest of the points are okay. So make sure you are giving the correct example for this particular case. Okay, so let's go ahead. So this is basically difference between maximum and minimum boiling isotope. That is also something I have discussed. One shows positive and another shows negative deviation. Example is one of the most mandatory part for this case. Okay. Next, what is the reverse osmosis? One of its application. This particular case you can get diagram based question as well, as it is given in the model paper. Okay, so the normal definition, I guess you can do it now. And here, what is reverse osmosis and how it is used for the desalination of water, that is also explained over here, you can see. Let's go ahead. Here you can see explain bends, anoxia and edema. Very important question. So bends is basically that is faced by scuba divers. Okay, so when more nitrogen gets dissolved in blood. Next, anoxia, it is basically less solubility of oxygen in blood whenever you are in higher altitude or in low pressure gradient zone. Okay, next is edema. It is basically the water retention in the tissue. Next, here you can see why the vapor pressure of the solvent decreases on addition of non-volatile solute. So what happens whenever you are adding non-volatile solute? Whenever you are adding non-volatile solute, that time what happens, that solute particles being non-volatile, they get accumulated on the surface area of the volatile solvent. As a result of this, what happens? The solvent molecule cannot get vaporized from the surface zone. Okay, so I guess this is clear for you. This is the answer. Complete explanation is there. You can go through once. Why the freezing point decreases on adding the solute? Again the same question, same type of question basically. So because of the addition of the non-volatile solute, the vapor pressure decreases. That's the reason freezing point also decreases. Boiling point of the solution increases. Why? Because again, to boil a solution, you need vapor pressure to be equal to the atmospheric pressure, right? Now vapor pressure is decreasing, right? Vapor pressure is decreasing because of the addition of the non-volatile solute, right? So as a result of this, boiling point means you have to give more temperature to make it vaporized. Okay, let's go ahead. This is the graph for that. And this is the boiling point graph, this is the freezing point graph. Okay, let's go ahead. See, this is the question I am telling you. It is very, very important. Last which year it came, that also I mentioned over here. Okay, and please make sure that you are going through this particular numerical. This numerical I have done multiple times, maybe in the 50 numerical video during the physical chemistry session as well. So make sure you are going through it. Next, this is the answer also, it is given over here. I'm not going for the thorough solving for this. I'm just showing this particular numerical is super important. Numerical video is pinned in the chat. Okay. Next, this particular numerical is way too important, most important numerical from the solution chapter for this year. Okay, so for this case, again I'm telling you, you can see, you can go and you can watch the video for the numerical session. You will get this video, you will get this numerical over there. Okay, the answer is also given here, 57.27. okay, next let's go ahead. calculate the osmosis. This is also very important numerical. In the model paper I solved it, in the 50 numerical session I solved it, in the physical chemistry session also I solved this particular problem. So yes, so this case, this numerical you have to go through, and this is the answer for this 30.9 Pascal. Make sure you are converting the unit at the end. Okay, last day itself I did it. Okay, let's go ahead. So let's go ahead towards the chemical kinetics chapter. So in chemical kinetics, majority you have to proceed with the graphical problems and some numerical. Okay, theoretical questions are very less out of it, but still you can see. First is pseudo first order reaction. It's a very important question, and as you know the answer, the higher order reaction that can be converted to the into first order reaction when any one of the reactant will be kept excess, right? Example of the pseudo first order reaction is also very much important. Next, here you can see what are the main criteria for the effective collision. For this year, this question is super important. Okay, so here you can see activation energy and proper orientation of the molecules. These are two factors. Next, this is another 2-marker question. Explain the effect of catalyst on the rate of a reaction. Super important for this year. So what you have to do, you have to proceed with this particular graph where reactant and product without catalyst you have to show, and in presence of catalyst you have to show, and you have to show the change in activation energy, that how it reduced down. Okay, so I guess it is clear. Let's go ahead. This is order and molecularity difference. Again, one of the most important question. So differentiate in between orders and molecularity. Any 3-point or 2-point you can pick in accordance to the mark. It can be given as, majorly it is given in 2-marker question. If it is given in the 3-marker as well, you can go ahead. Okay, so yeah, let's go. Write Arrhenius equation, state as to what the symbols stand for. Any very important question for this year. K equals to A into e power minus A by RT. So make sure whenever you are writing Arrhenius equation, then that time you are mentioning all the abbreviation correctly. So students, whatever the questions and answer you can see here in the PDF. Yes, I'm rushing a little bit because all the things are well explained in last few classes. I don't want to take that much time of you. Better if you revise these things. Okay, self-study. So I want you to tell, like the session, subscribe the channel, join the WhatsApp channel, and you will get the PDF as soon as the video will get, the live session will get over. That's my assurance to you. So yes, make sure you are going through this question. That is most important. My ambition here just to show these questions are important, guys. This is the last night study. If you even have not studied, if you have not touched the book, then these are the questions. Go and study. That's the thing. Okay, so let's go. So now explain the Arrhenius theory of activated complex. Very important question for this year. Okay, so activated complex means whenever the reactant, they will react, and you can see this is the graph that will come out of it. So whenever H2 and I2, this will react, it will reach the activation energy barrier and it forms an activated complex. The activated complex is basically neither the reactant nor the product. It is basically in between. Right, it is in between. So once it reaches the activated complex, it's a very unstable one, and from here it comes back to the stable product. Okay, I guess this is clear. Let's go ahead. Using the energy distribution curve showing temperature dependence of the rate reaction, explain the effect of temperature on the rate of the reaction. So that is nothing but the Maxwell-Boltzmann curve. Okay, so basically as you can see, whenever this is the fraction of molecule, NB by NT means this is the fraction of molecule, and here energy. If you are having temperature T, then you are having only this many fraction of molecule. right, that are crossing the threshold energy. But whenever you are increasing the temperature by 10 degrees Celsius more, then you are having more fraction of molecule that are crossing the threshold energy. So that's what you have to explain here. Okay, let's go ahead. Name the factors affecting the rate of a reaction, or on which factors does the rate of a reaction depends. So basically these are the factors on which the rate depends. You can see nature of the reactant, temperature, concentration, catalyst, presence of light. Okay, these are the factors on which you have to go ahead. Okay, let's go. See, derive an expression for integrated rate equation for zero order reaction, or derive the zero order reaction and first order reaction is something that you must do. Okay, so here you can see it is a already derived version, so you have to start with a normal reaction. Okay, so if you start with a reactant to product, from here differential rate equation you write at first, and then from rate law also you can write, then you can equate them, then you can do the integration. Once you are done with the integration, you will end up with an integration constant. Find out the value of integration constant by putting these conditions, okay, and then substitute the value here and you will get it. Okay, but in sometimes what happens, the way I used to teach you, that while doing integration you can put the limits as well over there. So if you put the limits over there, then directly you will get to, like, you will end up with this equation. Okay, you don't have to calculate the value of I individually. Okay, so yeah, let's go ahead. So now derive the expression of the half-life period for a zero order reaction. Okay, half-life, whenever you are writing in the same equation, is basically you are replacing this R value with R naught by 2. So once you are replacing R with R naught by 2, you will end up with this equation. Okay, T half equals to R naught by 2K. From there I can tell that the half-life of the zero order reaction, is basically depends upon the concentration of the initial reactant. Okay, let's go ahead. So this shows T half is directly proportional to the reactant concentration. Next, this is the first order reaction derivation. Here you can see the entire derivation. Okay, in the physical last night itself we did this entire discussion how to derive it. I like taught you that time. Okay, so here you can see, just for a revision, so start with a normal equation, then write the rate law, write the differential equation, equate them, right, then do the integration. Okay, find the value of I here, find the value of I by putting everything, the T equals to 0 and R equals to R naught. These are the condition to find out I, right? So from there I value you put into the main equation. So main equation, just a little bit rearrangement can give you this thing. Okay, so from here whatever the graph I got, that also I explained over there. Okay, so one more time I want to show it to you. So basically if you have ln A naught versus T graph, it will be like this with a slope equals to minus K. Okay, so that is basically I am doing it for the first order. Now same graph if I am doing it with respect to log of A naught versus T, there are difference in between ln and log, that also last day we explained. So here you can see slope value you will get minus K by 2.303. Okay, let me tell you the intercept as well. This is basically AT, this is AT. Okay, and the intercept value you will get ln of A naught. Okay, and the intercept value you will end up with a log of A naught here. Okay, so now another one graph that also I showed. So log of A naught versus AT, A naught by AT versus T graph, if you do, it will pass through the origin with a slope equals to K. Okay, for this case intercept will be 0. I guess it is okay. Let's go ahead. Okay, show that the first order reaction half-life period is independent of the final concentration of the reactants, or derive the half-life period for the first order reaction. So nothing, just in the same equation, what you have to do, you just have to replace this R with R naught by 2, okay, and you will get this equation. It's a very important thing for the numerical purpose. Next, derive integrated rate law for the first order gas phase reaction. So I did the derivation, so ultimately you will end up with this thing. Just with a quick thing, let me just go ahead. A plus B, A gives B plus C. Let's start with this, and if I start with P initial, let it be 0, let it be 0 when T equals to 0. Now when T equals to T, it should be Pi minus X, so this should be X, this should be X. Now total pressure, if I want to find out, it should be Pi minus X plus X plus X, total this, okay. So now if I find out, you will get Pi plus X. So from here, P total, I am getting Pi plus X, hence X equals to Pt minus Pi, right? This is one important thing. Now let's say pressure of A is Pa, okay, so Pa is Pi minus X, Pa is equals to Pi minus X. Now in the X we will put this value, okay, Pi minus Pt plus Pi, right? That's what is happening. If I replace the value over there, now from here you are getting 2 Pi minus Pt, right? So now in the first order rate equation, if you write T equals to 2.303 by K log P naught by Pa, right? Let's put the value here, 2.303 by K log P naught is what? Here I have taken Pi. So Pi by 2 Pi minus Pt, that's it. Okay, this is your gas phase equation. Okay, for this particular equation you don't need to go for the graph. I guess this is clear. Let's go ahead. Okay, so here you can see numerical problem that already I did here. Okay, let me just check what's going on here. My goodness. So better without like thinking so much, just look what I'm doing, okay, that's really gonna be helpful. Okay, this revision can ensure that you are getting 60 plus marks, because here only I am discussing about the important questions. Yes, MCQ I will not discuss here because we already had spent a lot of time for the MCQ. So if you want further MCQ, you can go and you can check that, okay. So for these question you can assure 60 plus marks if you have done properly. So make sure you are watching this properly, okay. So this is the question. I'm not going to solve it here. You can see in the chat the link is pinned already. You can go and search for this numerical portion and you will get this numerical from there, okay. So answer is also given here. You can see this particular graphical based question, it's very important for this year, okay. One case you have to find out the A value, that is a pre-exponential factor, okay. So if you are writing the graph, log K is basically equals to log of A minus EA by 2.303 RT. Okay, so this is basically the equation, Arrhenius equation, right? So log A is the intercept. So log A value they have given, right? Log A value you can see they have given 10. From here you can calculate A, that will be 10 power 10. Okay, from this is your this is your slope value. So minus EA by 2.303 R is given as minus 5.1 into 10 cube. If you calculate this and find EA, you will get the answer, okay, in kilojoule per mole. So I guess it is okay. Let's go. Okay. This is also Arrhenius equation. We did this multiple times. I guess you can do it. What you have to do is here. So log K2 by log, sorry, wait. Okay, so if I just write down the formula, log K2 by K1 is basically equals to EA by 2.303 R 1 by T1 minus 1 by T2. Okay, utilizing this formula you have to find out EA. That's it you have to do. Let's go ahead. Here you can see this is an initial rate method, so you have to prepare the equation for this case. 3 equation you will get from there, x and y value you have to find out. Okay, so let me just show you a little bit. So let's say R equals to K into A power x into B power y. So rate is basically given as 2 into 10 power minus 3 into K into 0.2 into 0.3 power x power y. So like that you have to prepare this 3 equation. From these 3 equation you have to solve for x and y. Okay, so once you are done with the x and y, you will get the value, I mean you will get the order of the reaction. Okay, so what is the rate constant? Rate constant, in order to find out the rate constant, you first find out the order. Okay, let's say I am getting x equals to 1, suppose. Okay, suppose x equals to 1 and y equals to 0. Okay, so any one value you take, so 2 into 10 power minus 3 equals to k into 0.2 power 1, 0.3 power 0, right? So this thing will be gone because something power 0 means 1. So from there k becomes 2 into 10 power minus 3 divided by 0.2. Okay, so like that if you just calculate any one value you can pick. Okay, you can just find out the value of k. Okay, half-life of the reaction. See, half-life of the reaction depends upon like what is the order of your reaction. If overall order comes as 1, then you can go ahead with the half-life of the first order reaction. You can apply the formula and you can go ahead with the answer. Okay, so yeah, let's go ahead. Again, this type of question, this is a very super easy type of question. Let me just show you a little bit. Here you can see in a chemical reaction A plus B gives C plus D. In the concentration of a reactant, A alone increased by 2 times. Okay, let me just write the rate first. So rate is basically equals to small r, basically equals to k into again A power x B power y. Check whatever the statements they have given. The concentration of reactant A alone increased by 2 times. So let's make it 2A. 2A power x B power y, right? Then they are saying R will be increased by 4 times. It will be 4R. Like that you have to predict the equation. If the concentration of both A and B are increased by 2 times, let it be K into 2A into 2B power y. Okay, the rate is increased by 8 times. It will be 8R. So now you have your equation. This is your equation 1, 2, 3. Okay, from this equation you have to find out the value of x and y. That's it. Okay, I guess this is clear for you. Okay, so here we are going to discuss about the coordination compound. Okay, so let's do some most important questions only. So here you can see, explain with 2 examples, each of the following: chelating ligands, homoleptic complex, heteroleptic complex, and ambidentate ligand. These are the definition based question. You can see here comes the entire definition. So you can go ahead with this. Chelating ligand means you have multiple donor side, they are donating simultaneously. Homoleptic complex means a metal will bind with only one type of ligand. Heteroleptic means the metal will bind with different type of ligand. Ambidentate ligand means it has two donor side but it donates from one side at a time. Let's go ahead. Okay, here comes another important question. Draw the isomer of this species. I will show you how to draw the isomers. So for first cases I will see cis and trans, and cis again will show optical isomerism. Very important question, my dear, very important question for this year. Okay, yeah, beta, electrochemistry I will do last. Okay, these are the high priority chapter that can give you 63 plus almost. Okay, so I'm ensuring that this chapter you have proper grip. Already I taught you all the chapter thoroughly, but still some important thing can give you 63 plus very easily. Okay, let's do them, and let's at the end we will go ahead with the electrochemistry. Okay, so let's go. So let's draw the structure. Let me just change the ink. So platinum, so let's draw it. First we will draw the trans, okay, because trans is optically inactive. Cl, this is your trans. You can see symmetry element are passing through it, so it is optically inactive. Now I will draw the cis. So Pt, this is another one, En. This is your cis. Now you can see cis isomer is basically optically active, and hence you will get D and L isomer. So Pt, if I draw that L as the mirror image of it, so let's draw it like this. Here another ethylene diamine, here Cl, here Cl. So these three are all isomers of the first compound. Okay, I guess this is clear. Second compound, if you just see, it's a completely optically active compound. Again I will get D and L. Okay, so let me draw it for you. This is how you should draw the compound and then its mirror image. So if I draw the mirror image, it will be something like similar. It will be something like this. If this is your D, this will be your L. Okay, I guess this particular thing is clear for you. Yeah, let's go ahead. Oh, sorry. Okay, so here you can see another most important problem. That is, you can see out of the following two coordination entities, which is chiral, that is optically active, cis and trans, which one is optically active? Let me tell you, cis is optically active, trans is not. Okay, because symmetry element is present over there. Draw the structure of its enantiomer. So let's draw the structure of the cis. So I'm having chromium a little bit below. Let me draw it here. Okay, so Cr, oxalate, right? So oxalate, you can represent it like this. Here Cl, here Cl. Okay, now mirror image if you draw, that is Cr, here one oxalate, here another oxalate, here Cl, here also Cl. This is your D, this is your L. I guess this is clear for you. Let's go ahead. Okay, so now you can see, state the postulates of Werner's theory. So here comes the Werner's theory's postulate. You can talk about primary valency, secondary valency, how they are getting satisfied, one by ligand, another one by the charge, okay, and how they represent the spatial arrangement and coordination number as well. Let's go. Explain the linkage isomerism and ionization isomerism. So let me tell you, my dear, all type of isomerisms are important for the definition and example purpose. Okay, so here you can see this is for the ionization, this is the example, this is for the linkage, this is the example. One more question can come, linkage isomerism arises because of which type of ligand? So your answer is going to be ambidentate ligand. Okay, let's go ahead. This is basically solvation isomerism and coordination isomerism. Just see, the ligand will be exchanged, that is coordination isomerism, and solvation isomerism is number of water inside the coordination sphere and outside the coordination sphere will vary. Next, draw the isomer. Again, draw the isomer. For this case, if you are having MA3B3, very important question, MA3B3 type of ligand if you are having, then you will be having two type of isomer, that is FAC and MAR. Okay, so yeah, if you are having M is cobalt here. Okay, let me draw it with respect to cobalt itself. Cobalt. Okay, so first we will do the facial. Oh, sorry, it is ligand given, right? So the ligands are basically NH3. Let's take NH3, NH3, NH3. Here Cl, Cl, Cl. This is your facial. Okay, this is your facial. Let's do the meridional. So cobalt. Here Cl, 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 this is NH3, NH3, NH3. Okay, this is your meridional. Okay, I guess it's clear. Let's go ahead. Explain the hybridization of this particular complex. So cobalt 3 plus, right? It is basically your D6 complex, I mean D6 compound, right? So D6 means if you draw 1, 2, 3, 4, 5, hybridization, one problem I will do only. Okay, whoever is having doubt related to hybridization, please watch this completely. Okay, so here you can see, let's draw D6, 1, 2, 3, 4, 5, 6. This is your 3D6, this is your 4S, that is empty. Next it is your 4P. This is your 4P, right? That is also empty. Now in presence of a ligand, that is ammonia. Ammonia is a strong field ligand. It will force pair the electron. Okay, it will force pair the electron. As a result of this, it will paired up against the Hund's rule. 1, 2, 3, 4, 5. So you can see they will be getting paired up against Hund's rule. Now they will take part in the hybridization. So 2d orbital, 1s and 3p. Hence d2sp3. So d2sp3 will always give you octahedral geometry. And as you can see, there are no unpaired electron. You can call them diamagnetic. Diamagnetic. I guess this is clear for you. Let's go ahead. Okay, synergic bond in metal carbonyl that has both S and P character. This particular diagram, if you draw, it will be more precise. The answer will be more precise. Okay, so metal at carbonyl at first give the electron. It makes the sigma bond with the metal. It gives the electron in the vacant d orbital of the metal, and then metal gives the electron cloud back to the pi star antibonding of the carbonyl. That is the synergic bond. Let's go ahead. Limitation of CFT and limitation of VBT. Important question. You can see VBT, they cannot predict the some magnetic data. They cannot predict the color. Kinetic and kinetic stability and thermodynamic stability also cannot be predicted. Okay, so these are the limitations. CFT, CFT basically the limitations are something that is, it consider ligand as a point charge, okay, and it does not consider the covalent character of the bonding. Okay, let's go ahead. This is basically your octahedral splitting. This is your octahedral splitting, d orbital splitting in in any ligand, in presence of any ligand in crystal field. Okay, so basically here 5d orbitals are there. You can see 5d orbitals will be separated or will be splitted as Eg and T2g. Okay, Eg will go up, they are basically dx square y square, and below they will be dxy yz and dzx. Okay, mention the barycenter, and above the energy is 3/5 delta O, below the energy is 2/5 delta O. Okay, let's go ahead. So this is basically your tetrahedral field. Tetrahedral, what happens basically, T2 will go up and E will go below. So if in case tetrahedral chance coming this particular question and this particular question, if you ask me, this is more relevant for upcoming examination. Okay, their chance is higher, okay, rather than this, but this is also important. They can give any one of it. Okay, so in case they are giving tetrahedral, make sure you are writing only T2 and E. There should not be any G. Okay, let's go ahead. We will discuss about the D and F block element. Okay, so again I am telling you, if you need this PDF, that is for the fixed question, again and again I am telling you, fixed question that you must do for your examination. Okay, it's a kind of paper predictor. So yes, if you need this PDF, like this video, subscribe the channel, join the WhatsApp group, then you will get the PDF, because all the PDFs of the session will be shared there in the WhatsApp group only. Okay, so yeah, let's go. D and F block. Sure short question only we will discuss. Magnetic moment we can predict with the formula mu equals to under root n into n plus 2. N is the number of unpaired electrons, so whatever the number of unpaired electron you put and find the value in Bohr magneton. That's it. Let's go ahead. Here you can see, explain the formation of interstitial compounds. So interstitial compounds are basically whenever small elements, carbon, hydrogen, nitrogen, they get trapped inside the lattice. Okay, lattice of the metals. You can see these are some interstitial compound, TIC, MN4C. Okay, what are the properties of interstitial compound? These are also important. That is high melting point, they are hard in nature, chemically inert. These are the properties of it. Let's go. Explain the catalytic property of the transition metal. So here you can see why the catalytic property comes out, because of the variable oxidation state, large surface area of the adsorption of the reactant, presence of incompletely filled d orbital, formation of intermediate compounds. So these particular things will make like the activation energy lower. That's why they can act as a very good catalyst. Okay, so yeah, let's go ahead. What is the composition of the mixed metal? It's a very important question for the 2 marker. Okay, lanthanide 95%, iron 5%, traces of sulfur, carbon, calcium and aluminium, where they are used in the magnesium based alloy, okay, to produce bullets. Let's go. Cerium, why cerium shows +4 oxidation state? Very important, okay, because it shows in +4 oxidation state it will get the xenon like electronic configuration, that is an inert gas. Next, what is the highest oxidation state shown by actinoids? That is +7. What are the components? Neptunium and plutonium. Going ahead, how is potassium permanganate is manufactured? So even if you are not doing D and F block element, make sure at least you are going through this problem. Please. One more thing that I want to tell, that is a thermal decomposition. thermal decomposition of KMnO4. That is also important. So KMnO4, I'm not balancing it, I'm just writing it because this particular, whenever they will ask thermal decomposition of KMnO4 will give you what? Okay, if you write the product, that will be more than enough. Okay, if you heat it, you will end up with K2MnO4 plus MnO2 plus oxygen. Okay, oxygen gas will be evolved, be careful about it. This question is asked. Let's go. How is potassium dichromate is manufactured? That is also an important problem. Okay, let's go ahead. Let's go. What is lanthanoid contraction? I guess you also know it is a must-do question. What is the cause of lanthanoid contraction? Give any two consequences of it. So here comes the answers. So gradual decrease in atomic and ionic radii. What is the reason? Poor shielding of D and F orbital. Another thing is, last question is two consequences you can do that it's difficult to separate them, right? Because their atomic and ionic radii are similar. Next, basicity decreases from lanthanum to lutetium. Let's go ahead. The study of actinide element is difficult. The reason here, first of all, they are radioactive, hazardous for our body, half-life are very short, okay, and they can be prepared in a very small amount, nanograms only. Okay, going ahead, lanthanoids and actinoids, these are the differences. You can pick any three out of it, okay, and you can go ahead with the answer. Next, why Cr2 plus is reducing and Mn3 plus is oxidizing? Just look at the electronic configuration, you will get. Because Cr2 plus is reducing, in case it is reducing, it will be having T2G filled up, half filled T2G. D4 to D3, right? D3 means half filled T2G, that will give some stability. Whereas manganese 3 plus, if it gets oxidized, then the electronic configuration changed from Mn3 plus to Mn2 plus, means D5 configuration that has some extra stability. Okay, so I guess it is clear. Let's go ahead. Why is the highest oxidation state of metal exhibited only in the oxide or in fluoride only? First of all, both of them are highly electronegative and very small size, okay, and because of this reason, basically they can be act as a, like, they can be taken by the metal to exhibit their highest oxidation state. Like we know oxygen, it forms like Mn2O7, okay, even KMnO4, their manganese forms +7 oxidation state, right? Let's go ahead. Which is the stronger reducing agent between Cr2 plus or Fe2 plus? Okay, the reason is again Cr2 plus is the stronger because it is having the T2G half filled. Okay, let's going ahead. Okay, why do transition element exhibit higher enthalpies of atomization? This is just because they are having more number of unpaired electron. Next question, enthalpy of atomization is maximum in the middle of each transition series because again they are having maximum number of unpaired electron. Next, in the series of scandium to zinc, the enthalpy of atomization of zinc is the lowest. Why? Because zinc has no unpaired electron. All the electrons are paired up only. Last one, enthalpy of the atomization is more in 4D and 5D series because of the heavy transition element can form metal-metal, strong metal-metal interaction. Okay, let's go ahead. Haloalkanes and haloarenes, important question, only we will do. See, Schwarz reaction, Finkelstein, Woods-Fittig, Sandmeyer. These name reactions are super important. So let's go ahead. Schwarz reaction, this is your Schwarz reaction. If you go ahead with the alkyl iodide, so basically for this case Finkelstein if you want to do, so CH3, let's say Br I am having, and I am giving the reagent sodium iodide in acetone. Okay, this question also may come. We covered it just today itself in the morning. Okay, CH3I, you will end up with, along with that, you will end up with NaBr. So this is the example of the Finkelstein reaction. Okay, so let's go ahead. So explain Fittig's reaction, Woods-Fittig and Fittig. Okay, so this is your Fittig reaction. Okay. Okay, so now let's go ahead with the Sandmeyer's reaction. So Sandmeyer's reaction, let's say if you are having benzene diazonium chloride N2 plus Cl minus, if you give Cu2Cl2 in presence of HCl, you will end up with the halogen over there, Cl, right? This is your Sandmeyer's reaction. Going ahead, give the preparation of aryl halide by Sandmeyer's reaction. Here you can see the same thing. I already wrote the reaction. This is the Saidzev rule. Saidzev rule says that more substituted alkene will be stable. So for this particular case, you have to give the example of this type of compound. CH2, CH, here hydrogen, here CH, let's say here Br, here CH2, here hydrogen. So this can also jam, this bromine will go and you will get the double bond here, and this can also jam, this will go and you can get the double bond here as well. Okay, so as a result of this, you can get two product out of it. You can get two product out of this, but major product will be this only, CH3, CH2, CH, double bond, CH, CH3, right? So this is your major product. Why? Because it is the more substituted alkene. Okay, that is the Saidzev rule. So while doing the beta elimination, more substituted alkene will be the stable one, major one, better to say. Let's go ahead. Okay, aryl halides are less reactive towards nucleophilic substitution. What is the reason behind it? First of all, the resonance effect. Next, sp2 hybridization. Okay, so what is resonance effect? Because of the resonance effect, in between carbon and halogen there exists a partial double bond like character, right? So because of the partial double bond like character, it's become difficult for them to separate. Okay, another one is sp2 hybridize. sp2 hybridization means we are having S character more. If you are having more S character, it means that the bond will be holding, I mean the two compounds will be holding strongly. Okay, let's going ahead. Write the steps involved in SN2 mechanism. So SN2 mechanism, if I just simply go ahead, that is, you are having, let's say, methyl chloride. Okay, okay, you are having methyl chloride. So what we will have, you will be having one nucleophile, let it be OH minus, it will attack from the back side. In the first step, you will end up with a penta-coordinated transition state, okay, here Cl, here also I am having OH, right? So here basically half delta negative, here also half delta negative, here I am having delta positive. Okay, this is your penta-coordinated transition state. From here the leaving group will leave the system and you will end up with a tilted version of the structure. Okay, so this is your hydrogen, this is your OH here, this is your another hydrogen. Okay, this is your another hydrogen. Okay, you will end up with this thing. Okay, so I guess this is clear for you. For this case, if you are starting with a chiral carbon or asymmetric carbon, then you will end up with a inversion in configuration. Okay, you will end up with the inversion in configuration. If you start with R, you will end up with S. Okay, let's go ahead. Water freons. Name the poisonous gas evolved when Cl2 is oxidized. You can see chlorofluorocarbon compound of methane and ethane, they are called freons, okay, and this is the compound COCl2 that you will get. So haloarenes para isomers have higher melting point as compared to that their ortho and meta. So the reason is basically para isomer, this para isomer is more symmetric. Okay, para isomer is more symmetric and hence they can be fit in the crystal lattice properly. That's why it's you need more energy to break the lattice. Next, okay, so if you wanna arrange them, if you wanna arrange them, so definitely molecular weight CHBr3, that is bromoform, that will come first. Okay, after that dibromomethane, that is CH2Br2. Okay, after that bromoethane, CH3Br. Okay, after that chloromethane, CH3Cl. Okay, next you can see, if you just go ahead with this thing, chlorobutane, 1 chlorobutane, 1 chloropropane, isopropyl chloride. Okay, so for this case 1 chlorobutane will come first, so let it be your number 1, let it be your number 1, let it be your number 2, let it be your number 3. Okay, so your third one will come first, then your compound 1, then your compound 2. Okay, let's go ahead. Chloroform is stored in closed dark colored bottles. Why? So this is the reason, basically it slowly oxidized in air in presence of light to give you the poisonous gas, this one phosgene. Okay, next, 3 difference between SN1 and SN2 mechanism. Identify A and B. Okay, SN1 SN2 mechanism difference, I guess you can tell that. Let me just show you the A. A is basically benzene diazonium chloride, N2 plus Cl minus, that is your A. Okay, and what is B? You just have to add Cu2Br2 in presence of HBr. That's it. Let's go ahead. Write the mechanism of SN1. Basically this is 2-bromo-true-methyl propane. Okay, so if I just draw this is basically Br, here CH3, here CH3, here also I'm having CH3. So for this particular case, if you want to undergo SN1 reaction, first step is basically slow. First it will form the carbocation, leaving group will leave the system and it will generate the carbocation. So here I'm having CH3, CH3, here I'm having CH3, here carbocation. Next, this particular carbocation will be attacked by the nucleophile. Let's take the nucleophile OH minus, so it will attack like this and it will end up with CH3, here CH3, here also CH3, here OH. This is your SN1 mechanism. So for this SN1 mechanism, if you are starting with a chiral carbon, then you will end up with a racemic modification or racemic mixture. Okay, so now I guess this is clear for you. Let's go ahead. Okay, what is enantiomer? What is racemic mixture? Enantiomers are basically the non-superimposable mirror image of the optically active isomers. Okay, next, racemic mixture is basically equimolar mixture of D and L. Let's going ahead. This is the answer, you can see, racemic mixture. Okay, so this is one type of problem. It's an entire 5-marker problem. So let's do it. So alkyl halide reacted with KOH to give compound B. Compound B reacted with HBr to give compound C. C and A are isomer. When A is reacted with sodium metal, it gave D, that is C8H18. That is different from the compound when N-butyl bromide is reacted. So definitely my compound will not be N-butyl bromide, it should be isopropyl bromide. Okay, so let's start with the isopropyl bromide. isobutyl bromide actually, isobutyl bromide. So CH, here I am having CH3, here I am having CH3, CH2. This is the only option now for the A. At the last they gave the hint actually. So this is basically your A, right? This is basically your A. Now here if you give alcoholic KOH, it will undergo beta elimination, right? So once I will get the beta elimination, C double bond CH3 here, here CH3, here CH3. Okay, this is your compound B. Okay, now this B, if reacts with HBr, if it reacts with HBr to give C, if it reacts with HBr, it will follow the Markovnikov, right? So here CH3, here also CH3, here I am having the Br, right? And here, sorry, this should be CH2, I missed it. This should be CH2. Here I will get CH3, right? So now this is your C, right? This is your C, which is an isomer. So now C and A, you can see they are isomers of each other. Okay, now if A it reacts with sodium metal, then Woods reaction will take place. As a result of this, you will get something like this: CH3 whole twice, CH, CH2, then CH2, CH, CH3 whole twice. Okay, so this is something you will end up with. Okay, if it reacts with sodium metal. So this is A, B, C, all the structure I have written, and this is the all, this is your D. Okay, this is your all the structure and the A, B, C, D, all the compound. Okay, let's go ahead. We will discuss about the alcohols, phenols and ether now. Okay, so yes, preparation of phenols from cumin. So many times I discuss this thing: isopropyl benzene, you have to oxidize it, cumin hydroperoxide, you will end up with phenol and acetone. Williamson ether synthesis, here you can see this is the reaction. Let me show you. If you are having one alkoxide, let's say RO minus Na plus, okay, plus R prime Cl, R prime Cl, okay, then this O minus will attack here and Cl will go. This is basically a kind of SN2 reaction, and you will end up with a ROR prime, that is a ether compound. Okay, that is also an important. Let's go ahead. Okay, so for this case, first case, you can see it's a 2-degree alcohol. Very important question. 2-degree alcohol, CH3, C, you will end up with ketone. Okay, now for this case, it is a phenol. If you treat this with zinc dust, you will end up with simple benzene ring. Next, for this case, I guess you know this reaction. You will end up with salicylic acid, OH here. Okay, now if you go ahead with the next thing, your B is going to be C, CH3, CH3, CH3. Here you will get I, right? Let's go ahead. Lucas reagent, that is ZnCl2HCl. Okay, how it will differentiate in between 1 degree, 2 degree, 3 degree. So 3 degree will give you immediate turbidity, okay. 2 degree alcohol will give you after 3 to 5 minutes, okay, and 1 degree will not react in room temperature. Okay, that's it. Next, if you go ahead, boiling points of alcohols are higher than their classes of organic compounds like hydrocarbons, ethers, haloalkanes of comparable molecular masses. Give the reason and why alcohols are soluble in water. All the reasons are basically the hydrogen bond. Okay, let's go ahead. Okay, next, what is rectified spirit, what is absolute alcohol, and what is denaturation of alcohol? So these are the answers. You can see rectified spirit means 95.5% ethanol and 4.5% water. Okay, absolute alcohol means 100% pure alcohol, ethanol. And what is denaturation? Basically commercial alcohol, they are added with the CuSO4 for the coloration in presence of pyridine for the foul smell. This is the denaturation. Okay, let's go ahead. Orthonitrophenol and phenol which is having higher pKa, because orthonitrophenol is more acidic. It is more acidic. Okay, hence pKa is less for this, because acidity and pKa, they are inversely proportional. Okay, so I guess it is clear. As a result of this phenol, that particular thing is basically will be having higher pKa value. Okay, let's go ahead. How do you prepare aspirin for from salicylic acid? This is also a very important thing, very important question for this. So if you start from the salicylic acid, if you start from the salicylic acid in presence of acetic anhydride, you will end up with the aspirin. Okay, this is the reaction. You can see salicylic acid in presence of acetic anhydride in presence of H2SO4 will give you acetyl salicylic acid. Okay, so the IUPAC name for aspirin is also important, that is 2-acetoxybenzoic acid. Okay, let's go ahead. Orthonitrophenol is steam volatile but not paranitrophenol. Why? Because orthonitrophenol, it forms intramolecular hydrogen bonding. Okay, orthonitrophenol, it will form intramolecular hydrogen bonding. Okay, and paranitrophenol, if you see, then this will form intermolecular hydrogen bonding. Okay, as a result of this, this is steam volatile. How to separate them? By steam distillation. Okay, I guess this is clear for you. Let's go ahead. Explain Cole's reaction, or how do you convert phenol to salicylic acid. So here you can see this is your Cole's reaction. In presence of phenol, carbon dioxide and NaOH, you will end up with salicylic acid. Okay, let's go. This is your Raymer-Tiemann reaction, very very important. In presence of chloroform and aqueous NaOH, you will end up with salicylaldehyde. Okay, next, what happens when diethyl ether is heated with limited amount of HI and excess amount of HI? Very important question. So if you are having diethyl ether, so that is basically CH3, CH2O, CH2, CH3. Okay, so if you give HI first, you will get one alcohol, that is CH3, CH2, OH. Along with that, you will end up with one iodide compound, CH2, CH3. Now, if you further give HI in it, this particular alcohol also will be converted to HI. So, CH3, CH2, I. Here you will end up. I guess this is clear for you. Okay, so for this case, explain the mechanism of the dehydration of ethene. This is the mechanism I already discussed with you people. OH in presence of H plus, it will form the protonated alcohol. Now, the protonated alcohol leaves, you will end up with a carbocation formation, right? So next, the hydrogen will jump to give you the ethene. Okay, so now here you can see the product. If I want to write here, for this case, you will end up with the carboxylic acid. Okay, and here you will get the OH. Okay, so this is the same type again we did. It will give you the alcohol and iodide, tertiary butyl iodide. Okay, I guess this is clear. Let's go ahead. Okay, so identify A, B and C in the following equation. So for this particular case, you will end up with both ortho and para substitution. Both ortho and para substitution of the phenol. Okay, now if you give zinc in the phenol, you will end up with this benzene ring. Okay, now in the ethanol, if you give sodium, you will get ONA plus water. Okay, how to prepare phenol from aniline? Let's go. So if you start from the aniline, if you give NaNO2 and HCl, and if you give the temperature 0 to 5 degrees Celsius, you will end up with benzene diazonium chloride, right? N2 plus Cl minus. Now here if you give, let's say, water, okay, you will end up with phenol. So this is how from the aniline to phenol conversion you can go ahead. Okay, let's go. Next, you can say explain the mechanism of dehydration of alcohols into the ether. Okay, so this is the dehydration mechanism. First it will be protonated, OH plus. Next this oxygen will attack on this carbon and this particular leaving group will leave the system. Okay, so as a result of this you will get this particular thing, and then this oxygen hydrogen bond will jump back to give you the ether. This is the mechanism. All the mechanism that we already did in detail, we discussed all the organic mechanism in the morning session. So here we are just revising. So for you people, if just one night before you are really feeling okay, today I will study, I will understand all the concept, okay, and tomorrow I will sit in the exam and hum paper 4 denge, okay, I will get 80 out of 70. Then you are absolutely wrong, my dear. Okay, this particular session is for the quick revision. Already you know these things and you are recapitulating, and these are the fixed questions that you are going to get in your examination. Okay, so that's the reason it's really needed that I become a little fast, so that after the recapitulation you get your own study time. Okay, so I guess whoever has doubt related to that, they never joined the live session whenever I have taken the big physical chemistry, inorganic chemistry live session. They were not there, okay, but they are here for the spamming purpose. Okay, if you feel like you can study and you can do better, go and do it, and whoever is the learner here, let them learn. Okay, so these are the important questions. I am doing the revision here, I am not teaching the concept. Okay, so I guess this is clear. Let's go ahead. So better if you leave the session and study by your own. I guess that will be fruitful for you as well and for me as well, so that I can concentrate here. Okay, so yeah, let's go. So basically next question, explain the mechanism of dehydration of alcohols into ether. Okay, so yeah, that's we did actually. Next question you can see, explain the mechanism of alkenes to alcohol. Let me show you the mechanism at first. This is the alkene to alcohol mechanism. First, you are having a protonated water. Protonated water means water when it is treated with H+. Okay, then this alkene molecule will attack over the hydrogen, and this oxygen hydrogen bond will jump over here, and you will end up with a carbocation. Right, now this carbocation will be attacked by the lone pair of oxygen, and you will end up with this compound. Okay, this particular compound, one hydrogen will be abstracted, and you will end up with the alcohol compound. Okay, I guess this is okay. Now here you can see, for this question, let me just go ahead. This will follow Markovnikov method. Okay, so let me just go ahead. CH3, first it is A. Okay, CH3, CH, here I am having OH, here I am having CH3. Okay, this is the product A. Now in A, if I give CrO3, I will end up with the ketone formation, that is CH3, C double bond O, CH3. Okay, I guess this particular thing is clear for you. Next, here you can see an alkene X reacts with H2O H plus to give compound Y. Compound Y further undergo reaction with CrO3 H2SO4 to produce compound Z. Write the IUPAC name of X, Y and Z. Okay, fine. So this is the same thing that we did in the last case basically. So here alkene means C3H6. C3H6 means it's nothing but the propane. Okay, so for this case if you give H2O in presence of H plus, so just last case we did, you will end up with CH3 CH OH and here you will end up with CH3. Okay, now what I have to do? Now for this case you have to give CrO3. CrO3 if you give, then you will end up with acetone, right? Okay, so this is basically your propane. If I write the IUPAC name, okay, this is basically your alcohol. So propan-2-ol, propan-2-ol. This is your propanol. Okay, let's go ahead. Which among the following compounds have the lowest and highest pK value? So this thing also we did, paranitrophenol, phenol, ethanol. So definitely paranitrophenol, this is the most acidic, right? So this will be having the lowest pK value and highest pK value will be for the, this is the lowest, right? pKa will be the lowest and cresol will be for the highest. Okay, just in the morning we discussed this thing. Okay, let's go ahead. Okay, so here you can see how phenol is prepared from the benzene sulfonic acid. Write the equation. So this is the equation. You can see benzene, you have to treat it with oleum, SO3H you will end with, and in presence of NaOH it will be converted to OH. Okay, how anisole reacts with methyl chloride? So this is the reaction, this is the Friedel-Crafts alkylation reaction. Anisole in presence of CH3Cl, anhydrous AlCl3 is also there, you will get ortho plus para. Okay, electron donating group on acidity. If you are having electron donating group, then acidity will decrease. Okay, so let's go ahead. Okay, can I skip aldehyde, ketones and carboxylic acid? So that's a very bad choice actually for skipping. Okay, if you want to leave any chapter, aldehyde, ketone, carboxylic acid is not a good choice. Okay, because a lot of name reaction comes over there and from there direct question comes. So don't skip aldehyde, ketones and ethers. Okay, better see now in this moment if you feel like you are not confident enough, then you can go for other options. Okay, but don't study anything new as of now. Okay, if you have not touched this chapter, then yes, you can go ahead with the other chapters as well. You have amines, you have biomolecules, make them, you are doing it properly. Okay, but aldehyde, ketone, carboxylic acid, leaving this chapter is not a good choice. Okay, let's go ahead. Okay, this thing we already discussed. Okay, so here aldehyde, ketones and carboxylic acid. So yeah, you can see if you can have some revision related to the question, reagents and all. So yeah, let's go ahead. So okay, someone of you in the morning session, they asked me that they want this reaction to be solved by me. So that's why I kept this reaction. It's an important question because it is from the model paper itself. So yeah, just give me a minute. Okay, so let's do first question. Identify the compound A, B and C in the following. So for the first case, it is basically Korehouse synthesis. Let me just draw the product for you. For this, you will simply end with CH3, CO, CH3. Okay, this is your A. Now you are having one methyl ketone unit, right? So it will undergo haloform reaction. So as it will undergo haloform reaction, you will end up with CHI3 precipitation. Okay, yellow colored precipitation. Along with that, you will get one oxidized product, C double bond O, O minus. Okay, now let's go ahead with the next problem. So again, I'm telling you at the last moment, if you're not confident enough to proceed with this type of problem, then just don't go for it. Okay, other options will be there. If you are confirmed that you can do it, all the reagents are common for you, then only go for it. Or else I don't think that uncommon question will come for your examination. So make sure that you are practicing whatever is given in the model paper, and this type of question, for this type of question I'm asking. Okay, because direct 5 marker they give. Again, for this question also, step by step, if you are writing the product, 1 or 2 product, if you have written correctly, you will get the part marks. Okay, so let me just show it for you. So this particular thing, C7H6O2, as I told you, that's 7 carbon system means definitely one benzene ring is there, right? It reacts with thionyl chloride to give Q. Q on the further undergoes a hydrogenation in presence of PDBSO4 to form R. Okay, I got one hint what Q can be. So Q must be one acyl chloride, COCl type of compound. Okay, so why I got it? Because it is the Rosenman reagent, right? So definitely your Q is this compound, benzene with COCl. Okay, so now this is your Q. So now from where I can get the Q? Definitely a compound that is with benzene ring, along with that one carboxylic acid. Check, it is the same thing here. Okay, here if you give thionyl chloride, SOCl2, if you give, you will end up with the Q. Okay, now in Q what you have to give? PDBSO4, hydrogenation H2 in presence of PDBSO4, Rosenman reagent, right? You will end up with the benzaldehyde. Okay, that is the reaction. So I don't know if she is here who asked me this question to solve. I guess it's okay. Yeah, let's go ahead. If she is there, she will be benefited for this question. Let's go ahead. Okay, explain the Gattermann-Koch reaction. IUPAC nomenclature you can just avoid. Anyway, this is ethanaldehyde, and this is also, you can name it with 1, 2, 3, right? So you can have prop 2-enal, okay, and this is your ethanaldehyde. Ethanal, simply we can end that. Okay, I guess it is okay. Explain Gattermann-Koch reaction. So this is your Gattermann-Koch reaction, benzene in presence of CO and HCl, in presence of anhydrous AlCl3 and COCl, you will end up with the benzaldehyde. Okay, so let's go ahead. Okay, so here some equation, direct equation actually, these are not tricky problems. You are having carboxylic acid, right? So let's take carboxylic acid one by one. We will do CH3 COOH. In carboxylic acid, what I am adding? PCl5. So PCl5 once you are adding, you will end up with CH3 COCl. That's it. Okay. Next, you are having formaldehyde and concentrated KOH. Okay. So basically, formaldehyde has no alpha hydrogen, right? This is a formaldehyde, concentrated KOH, right? It will undergo Cannizzaro. Okay, because there is no enolizable hydrogen, and hence it will undergo Cannizzaro reaction. So if it undergoes Cannizzaro reaction, then it will give you one carboxylate okay, along with one alcohol. Okay, next the formation of oxime from carbonyl compound. Here I am doing the 3. So if you are having the C double bond O, so oxime is basically this H2NOH. This oxygen and this hydrogen, they gets released in the form of water, C double bond NOH. Okay, this type of compound you will end with. Okay, next, among the formic acid and acetic acid, which is more acidic? Formic acid and acetic acid. So basically in the acetic acid you can see I am having one electron donating group. Electron donating group. So electron donating group always reduce acidity. Okay, hence formaldehyde or formic acid is the most acidic one. Okay, I guess it's clear. Let's go ahead. Okay, explain the preparation of carboxylic acid from the Grignard reagent, give the equation. Okay, so we can treat this, Grignard reagent with dry ice. Okay, I am showing you the equation for this. See, if you are having, let's say, CH3MgBr type of compound, CH3MgX, now you are having carbon dioxide, C double bond O, double bond O. This CH3 will attack here, this will open up. As a result of this, you will end up with CO minus double bond O, and here I will be having CH3. Right? Now if you just hydrolyze it, H3O plus if you give, then you will end up with CH3 CO here OH. That's it. Okay, I guess it is clear. This is your HBZ reaction. Here you will get alpha halocarboxylic acid. Okay, so yeah, let's go ahead. Okay, so for this case you can see with respect to the structure of carbonyl group, give the following: hybridization of carbonyl atom, sigma and pi bonds around it, geometry. So sp2 hybridization, 3 sigma bond, 1 pi bond, and trigonal planar geometry with 120-degree bond angle. This problem is very important. Explain the conversion of toluene to benzaldehyde by side chain chlorination. So if you are having toluene, chlorination will give you benzyl chloride. On being treated with water, it will give you the benzaldehyde. Okay, let's go ahead. Okay, so this is basically butane, like these are not that much important. You can go ahead with the Clemenson reduction. Okay, so here you can see Clemenson reduction. If you are having C double bond O in presence of zinc amalgam and HCl, you will end up with the hydrocarbon. Next, here you can see next question. This thing I did already in the last. This case I will do. This is basically Friedel-Crafts acylation. Okay, so you will end up with the COCH3 group with it. Okay, let's going ahead. Here you can see this is the next question. X, Y, Z you have to find out at first. So if you give Mg here, so your X is going to be this particular compound with NO2. Here you will get MgBr. Right? Next, if you do carboxylation, C double bond CO2, okay, then you will definitely end up with the carboxylic acid. So meta-nitro, and here you will get one COOH. Okay, so yeah, I guess this is clear. Let's go ahead. Okay, for this case, arrange the following aromatic carboxylic acid in the increasing order of their acidity. So this will be maximum acidic. Let it be A, let it be B, let it be C. Okay, so B is maximum acidic, then it comes A, then it comes C. Okay, let's go ahead. Okay, just a minute. Okay, this question you can see, between methanol and ethanol which would undergo aldol condensation. So basically methanol will undergo aldol condensation they are asking. Okay, so basically ethanol will undergo aldol condensation reaction because these are having alpha hydrogen, right? Write the chemical reaction involved in it. So if I am having ethanol, let's say CH3 C double bond O hydrogen, I am showing you the aldol condensation reaction, it's an important one. So now another aldehyde I can take here hydrogen, here double bond O, here hydrogen. So this oxygen will takes up the hydrogen and this carbon and this carbon will make the bond. Okay, so CH3 C, here I will be having OH, here CH, CH2, here CHO. Okay, further if you heat, dehydration will take place and you will end up with a alpha beta unsaturated carbonyl compound. Alpha beta unsaturated aldehyde. Okay, I guess it is clear. Let's go ahead. Okay, how do you convert propanol to propane? So definitely propanol to propane you can do the reduction with the Clemmensen reduction or Wolff-Kishner, you can go ahead with this. Okay, so here you can see ethanoic anhydride formation by releasing of water, that also it's explained here. Let's going ahead. Okay, so now important chapters we already covered. Now optional chapters that we can go ahead with the amines. So in the amines, some direct straightforward question we can go through, that is the coupling reaction, para-hydroxyazobenzene, okay, formation, this is the coupling reaction, it requires the alkaline media. Next, you can see the pKb of aniline is more than that of the methanamine because of the resonance. Okay, next, write the general equation for the Gabriel thalamide that I am showing. This is the carbylamine, that is also important one. Carbylamine is primary amine. It's a confirmatory test. In presence of chloroform and KOH, you will end up with the isocyanide compound. Okay. Next, this is the increasing order of their basicity. Okay. So first you will start with the methanamine, then normal ammonia, then aniline. Let's go ahead. This is your Gabriel thalamide synthesis. Okay, this mechanism is very important. Go ahead with it. Okay, just give me a minute. Okay. Okay, so this is your Gabriel thalamide reaction, right? Okay, let's go ahead. Hinsenberg reagent and Hofmann-Bromamide degradation. This is your Hofmann-Bromamide degradation and this is your Hinsenberg reagent. Reagent itself is very much important at the entire reaction. Okay, so with primary amines, whatever the compound you will get, that is soluble in alkali. In secondary, it is not soluble in alkali. And for the third case, for the tertiary case, it will not react with the benzene sulfonyl chloride. Okay. Let's go ahead. Okay, an organic compound A on treatment with aqueous ammonia and heating with compound B, which heating with Br2 and KOH forms compound C. The molecular formula is C6H7N. Write the structure and IUPAC name of C6H7N. Okay, so I'm having a compound A. Sorry. Okay, on treatment with aqueous ammonia, I'm getting some compound B, okay, which on reacting with Br2 and KOH is basically the reagent for the Hofmann bromamide degradation, forms compound C. So definitely here I will get some amine, right, with the molecular formula C6H7N. Okay, write the structure of A, B and C. Fine. So here C6H7C means I can start with this. I can end with this actually, NH2. Okay. Now from where it came? That is B. That is we are having one amide, CONH2. From where this amide, NH2, sorry. From where this amide came? Definitely from the carboxylic acid. Okay, I guess it is clear. Let's go ahead. This is the next part. Scrap iron is used because to release the hydrochloric acid during the reaction. Okay, next one is solubility of aliphatic amines decreases with decrease in molar mass. This is basically the hydrophobicity increases. Okay, let's go ahead. So we are going to discuss about the biomolecules. So in biomolecules, few important question here you can see. Tertiary structure of protein, two major molecular shapes, right? The reaction that shows the glucose contain 5 OH group, then Zwitter ion. Okay, one by one here you can see this is the tertiary structure represent the overall folding. So entire shape determination of the protein or differentiation of the protein with respect to its structure, that is entirely important. Okay, so here you can see if you react this glucose with acetic anhydride, you will end up with the pentaacetate compound. And Zwitter ionic structure of glycine, if you want to write, so basically it is a proton donor. If you see CH3, COO minus, and here I will be having NH3 plus. Okay, this is the Zwitter ionic formation. Let's go ahead. So this is the structure of maltose. Okay, next, what is peptide bond? Okay, peptide bond means the bond between two amino acid. Whenever COH and NH2, they releases 1 unit of water. Okay, that is the peptide bond. This is the maltose structure, very important for your exam. And this name of the protein present in here, that is basically the keratin. Next, water reducing sugar. Give example: naturally occurring and optically inactive amino acid. Name any one of the vitamin. Okay, so here you can see the questions, I mean the answers. So the carbohydrate that can reduce tolerance and Felling's reagent. Okay, example you must give. Now glycine is one of the optically inactive amino acid, and name any one of the vitamin that's stored in our liver, that is vitamin A, D, E, K. Okay, fat soluble vitamin. Let's go. What are anomers? You can see these are the definition of anomers, and give 3 limitation. Here comes 3 limitation. One, you can discuss about the Schiff base. Next, pentaacetyl glucose, that particular cannot react with the hydroxylamine. Okay. Next, it cannot explain about the alpha beta anomer. Let's go ahead. Write the Howard structure of lactose, denaturation of protein with example, and water soluble protein. So this is the Howard structure of the lactose. Here comes the denaturation, means when protein loses its biological activity. Next, water soluble protein, you can give the example of any spherical protein. Spherical means like albumin, let's say, insulin. Okay, these are water soluble. So this is vitamins, mistakenly it is given. Okay. Okay, you can take the example of albumin, Okay, let's go ahead. What are essential amino acid? Give example, give the difference between DNA and RNA. So essential RNA, this is the DNA and RNA. You can write the sugar name. Sugar name for this case, it is basically deoxyribose sugar. Okay, and here it is basically ribose sugar. Okay, nitrogen base I use here. What is used here? Adenine, guanine, cytosine, uracil. For this case, adenine, guanine, cytosine, thiamine. Okay, essential amino acid means the acid which can't be synthesized in your body. So you can take the example of lysine, valine, leucine, etc. Okay. Okay, so now you can see oxidoreductase enzyme. So here you can see the example, the enzyme which catalyzes the oxidation. Okay, next give any one main source of the vitamin K, that is any leafy vegetable. Give reason. Sucrose is a non-reducing sugar because first of all, sucrose has no aldehydic unit to reduce Tollens or Felling's reagent. Okay, now what is invert sugar? Invert sugar is basically when sucrose is being hydrolyzed, you will end up with levorotatory fructose more. Levo-rotation is more than that of the dextrorotatory glucose. As a result of this, overall solution becomes levorotatory. Okay, I guess it's clear to you. Let's go ahead. So this is the difference between amylose and amylopectin. Okay, here comes all the disaccharides, polysaccharides and their monomer unit and their linkage. So once you will get the PDF, you just have a look on this, but majorly lactose, maltose and sucrose are most important. Okay, now we will do a little bit theoretical problem related to the electrochemistry. For numerical problem, you can go and watch the physical chemistry session that we took last night itself. So there you will see the important question out of it, and if you want only numerical, then you can go and watch the 50 numerical, top 50 numerical. Okay, the session links are given in the chat itself. Okay, let's go with the electrochemistry, a little bit chapter. So Faraday first law and second law, these two are important for this case. Construction of SHE is important along with the diagram, and working principle also you have to study for this. And platinized platinum, why it is used, very important question, 3 marker you can assure out of it. Next, H2O2 fuel cell construction and cathode anode reaction, overall reaction, it's also very important. Next, direct measurement of, this is not important, let's go ahead. Okay, if you see plot versus conductivity versus root C, this is root C, okay, versus root C for a strong and weak electrolyte. If I just draw it, it is in accordance to Debye-Huckel-Onsager, right? So lambda M versus root C, so it will be something like this. Okay, for the weak electrolyte, this is your weak electrolyte, and strong electrolyte, it will be something like this. This is for the strong. Okay, I guess this is clear. Write the equation represents. So lambda M equals to lambda M0, lambda M0, minus lambda M0 minus A into root C. Let me write it here. Lambda M equals to lambda M0 minus A into root C. Okay, so this is the graph that is in accordance to Debye-Huckel-Onsager equation. Okay, next, molar conductivity of dilation. Okay, that's it. Yeah, that's it for the electrochemistry. These are the most important questions that you should go through, because electrochemistry is majorly this subject is majorly a numerical based. So majorly, if you have enough confidence, go for the numerical problem, you will get common out of it. Okay, so any further thing if you need, You can see the video links are there. You can go and check it out. MCQ, numerical, whatever you want. Give one like, make sure, because we are giving a lot of effort for you people. Subscribe the channel, and again tomorrow morning with the most important formulas and whatever the last 1 hour revision that we call. With that I will come. So wake up early in the morning, 4 a.m. I will be there in the live session for you people. Entire chemistry in 1 hour we will discuss. Okay. So yeah. No, in mechanism you should not write that much explanation. It's not needed actually. Okay. In the mechanism just write the step name. Okay, and go ahead with the mechanism. 3 steps maximum you will get. So 3 marker problems are those. Okay. So yes, after the session, if you only like the session and subscribe the channel, you will get the PDF. Otherwise, no, there is no chance. Okay. So now whatever the problems you had, the model paper, if you have been through, then yes, very good if you have done the model paper. So definitely the question that we assembled here, they are from the model paper, question bank analysis, and also the previous year questions as well. All of them on being analyzed, we come up with the suggestion. So please make sure, and so many of you are telling that we are not understanding, no, nothing like that. So basically I am not here to teach you the concept here. It is just a quick revision that look at this question, this may come in your upcoming examination. Now this is the time for your self-study. Go and study. Tomorrow morning wake up early and make sure you are joining the last minute revision. So yes, all the very best for your final examination. Yes, I am also worried for you people. I am also in tension because it's also my effort as well that I am giving for you. So yes, all the very best. Good night. Tomorrow morning we will meet. Thank you so much. Bye.